Introduction to Roundabout Design. Roundabouts, one of the simplest, safest, and most efficient forms of intersection design. But behind the simplicities lies a set of engineering rules, geometry, and precise calculations. In this lesson, we will explore the fundamentals of roundabout design, what they are, why they matter, and how engineers choose the right type of each project. What's a roundabout? A roundabout is a circular intersection where vehicles travel counterclockwise around a central island. The key principle is simple. Vehicles entering must yield to vehicles already circulating. This reduces conflict points, lower speeds, and vastly improves safety. Why roundabouts are safer? Compared to a traditional four-way intersection, a roundabout removes the most dangerous types of crashes, head-on and right-angle collisions. According to the US Federal Highway Administration, roundabout can reduce severe crashes by up to 76% simply because they slow vehicles and simplify driver decisions. Key components of roundabout. Every roundabout, big or small, shares the same core elements. First, central island, the raised center that defines the circular movement. Circulatory roadway, the lanes where vehicles circulate around the island. Spiritual islands, these guide in turning traffic, slow vehicles, and create safe pedestrian refuge areas. Entry yield line, the point at which entering vehicles must give way. Truck apron, a mounted ring around the central island, used when large trucks need extra turning room. Together, these components create a system that controls speed, organizes movement, and protects both drivers and pedestrians. Types of roundabouts. Roundabouts are not all the same. Engineers choose from several types depending on space, traffic volume, and design requirements. Mini roundabouts, a very small circle, often with a mountable center, perfect for neighborhoods or tight urban areas. Compact urban roundabouts, slightly large, used in cities where space is limited but traffic demands are moderate. Single lane roundabout, the most common type, one lane circulating, one lane entering and exiting, ideal for suburban and rural intersections. Multi-lane roundabout, two or more circulating lanes designed for high-volume intersection or major arterial roads. Each type has design standards for diameter, lane width, and entry geometry, ensuring safe and predictable operation. Fundamental design principles. Regardless of the type, all roundabouts follow essential engineering principles. Speed control through geometry. Entry curvature forces vehicles to slow down. Yield at entry control. Drivers entering must give way, creating smoother flow. Design vehicle accommodation. Dimension must allow trucks and buses to navigate safely. Pedestrian and cyclist safety. Crosswalks, visibility, and refuge island must be planned carefully. Balanced geometry, entry and exit width, radii, and lane both must all work together. These principles ensure a roundabout performs well, remains safe, and meets real-world traffic needs. When to use a roundabout? Roundabouts are ideal when an intersection experiences high crash rates, traffic flow varies throughout the day, turning movements are heavy, speed reduction is needed near residential or urban areas, pedestrian and bicycle safe is a priority. Now that you understand the fundamentals, it's time to move into Civil 3D and begin building the foundation of your roundabout. In the next lesson, we will start with the geometry, creating the circular alignment, defining the main diameter and preparing the model for full design.